Hey y'all, we are going to finish up on or keep going on our significance testing. We'll see if this gets too long. Remember, you want to have this out, right? Your little formula sheet. It's a whole lot easier to just have it to look at. Hit pause if you need to write it down if you've lost yours. All right, there we go. So last time I told you that we have pretty good evidence, but we were going to look more at the numbers. So today we want to look at, do I have evidence? Do I have some evidence, strong evidence? How certain are we that these results are good, right? That's the whole key. With statistics, we want to look at a sample, try to make predictions about a population, but we want to know that what we're saying is true. So we've got to do this test to say, is this true or could it happen by chance? Sometimes things happen by chance, right? And we get all excited and we say, oh my gosh, what's a miracle? We all have the same birthday or something happens. And that's what we're trying to check here is, did this just happen by chance? Or is there some statistical significance? Is it real? Is this really there? So let's look at this. Remember, the purpose of a statistical test is to answer the question, could the effect we see in the sample just be because of pure chance, or is it good evidence that the effect is really there in the population? Is it really happening? Is it really there? Is it really true? The probability is called the p-value. A small p-value means pure chance is unlikely. H0 says effect is not present. HA says the effect is present. Okay, so we talked about H0, the hypothesis and the alternative hypothesis last time. So let's look. Remember, in statistics, the word significant, this is important. Significant does not mean important. It means not likely to happen by chance. So if we say these results are significant, we mean this just didn't happen by chance. There's really a pattern here, or this is true, or this is going on in our population. If it's not significant, then we're like, oh, it's coincidence. That could happen though, right? We could have two kids in the same class with the same birthday. That's not weird. How will we know if our result is really statistically significant? In other words, how small does the p-value have to be? The decisive value of p is called the significance level and is usually called alpha. That's the symbol for alpha. The common threshold is 0.05, or if you're working with a fraction, 1 in 20. If the p-value is smaller than alpha, we say the data are statistically significant at level alpha. Okay? Guidelines, now these are not hard lines drawn in the sand. We've got to look at the context and everything with a problem, but as a general rule, guidelines for how much evidence is enough for statistical significance are as follows. There's more to come in a little bit, but a p-value of less than 0.10 indicates some. So 0.10 indicates some evidence against the null hypothesis, like, I'm not sure if this is true. If p is smaller than 0.05, then we have moderate evidence enough to be significant. Okay, so if it was less than 0.10, I might say, you know what, I gotta go get some more samples. I'm just not totally sure. If I'm smaller than 0.5, I'm starting to say, you know, I'm pretty sure. And a p-value of less than 0.01 is strong evidence against the null hypothesis, right? Remember, H0 is p equal, must have equal sign, and H0, I did this like this so you could draw the little line through it, never has equal sign, right? Only greater than, less than, or not equal to, right? What is a one-sided alternative? What is a two-sided alternative? Well, in a one-sided alternative, our alternative would be P is greater than or P is less than, and that's a right tail or a left tail, right? And in a two-sided, HA is not equal to. So we say, well, it might be bigger, it might be smaller, but I know it's not equal to. Here we're saying it's greater than or less than, right? And we are going to, here's some important lingo. You know how we love our statistical sentences and buzzwords. So we will reject if p-value is less than alpha. We do not accept, we never say accept, but we say we will fail to reject if the p-value is greater than alpha. So pause for a second and think about that. We're going to reject if our p-value is less than alpha, and our p-values are right here. You know what? This would be a good time. Take a second so you have everything in one spot, and let's go here and say p is less than 0.10, p is less than 0.05, p is less than 0.01. Some evidence. Well, against the no, but we're not enough to start really rejecting. This is moderate. And this must be important if it's typed and I'm writing it down anyway. This is enough to be significant. And then here we have strong evidence. Against null hypothesis, which is H naught, right? So in other words, if I get a p-value less than 0.01, I'm like, you're full of beans, that's not true, right? So write this on your formula sheet so that you have this nice, pretty everything in one spot, okay? So we are going to now look at an example. This is a real example, a famous example, I should say. All right, so let's look at this. The count, and he really was, tossed a coin 4,040 times. He got 2,048 heads. What is the sample proportion of heads? Remember, that's p hat. So that's 2048 out of 4040. And that is what, 0.507. Now that's about what you would expect, right? Because if we toss a coin. So maybe he wants to test this coin. We could do this with a fixed coin, you know, a coin that's not balanced. What do you call that? A coin where you want to fib to people and you, I can't think of the name of that. Okay, a fixed coin or a bad coin. Anyway, so what is H naught here? Well, when we flip a coin, we would expect the p-value to be 0.5, right? You should get heads half the time and tails half the time. H naught, H alternative is that it's not equal to 0.5. This is going to be two-sided because we're not saying it's going to be greater than 0.5, or we're not saying it's going to be less than 0.5. We're just saying it's not going to be 0.5. So do we have a one or two-sided alternative? We have a two-sided alternative because we can look, whoops, at either side of 0.5. We're not saying greater than 0.5 or less, just not equal to. What is the sampling distribution? Well, we know that P, now remember, P hat is what we really did. We flipped this coin. P is the truth. And what's the truth about coins? Well, the truth about coins is that they are 0.5. We know that if we flip a coin, we've done this in class together. What's the standard deviation? Get your little formula sheet out, and what is it? It's P times Q, which is 1 minus P, over, what's it over? Yes, the sample size, which in this case was 40/40. And that equals 0.00787. So we're gonna find our Z, right? So here's your steps. You have to know P, standard deviation, and Z. Z is on your formula sheet. It's the sample mean minus the mean over the standard deviation. So Z is going to be 0.507, so observed minus the actual mean all over standard deviation. So we have 0.88. Now remember, we're thinking about two sides to this story, right? There's the mean, but we want both sides, so we're going to have 0.88 and negative 0.88. You may have to go back into your memory banks. But this is because, let's draw an arrow. We look at either side. It's not greater than or less than, it's just not equal to. So that's why we have 2. Okay, so let's look at the p-value. So we're going to look up 0.88, right? We look that up on the chart and we get 0.8106, but remember 0.88 is here, so we want greater than and we want less than, so we're going to have to take 1 minus 0.8106, and that is, so we want to look above that number. Now we want to look below, so we're going to look up negative 0.88, and that's what, no big surprise, right? It's the same, right? Because whether you're above or below is going to be the same. So our p-value is all the area above and all the area below. So it's 0.1894 plus 0.1894. So 0.3788, right? So what does that even mean? What is this talking about? This means that this proportion of 20, what is it, 48 out of 40, right, would be expected. And remember, this is kind of one of your scripted sentences. Would be expected if HO is true. So it would be expected by chance 37.88% of the time. A fair coin, that's what it is. It is a fair coin. If a coin was not fair, if I had a trick coin. Okay, does that make sense? This outcome, 2048 out of 4040, 0.507. It's a little bigger than 0.5, but that's going to occur 37.88% of the time by chance. That's very good, right? We can go back to a couple of days ago and say, what's the 95% confidence interval? Remember our confidence intervals. So go back to your sheet, and we have to go to confidence intervals, right? So going back to a couple of days ago, we would say 0.507 plus or minus 1.96. Remember, this is a standard number for 95. And we're going to have p hat times q, and it's just 1 minus 0.507. If you need to pause this while I'm writing the formula down, once I write it down, please feel free to do so. And please type that into your calculator to make sure. But if we do 0.507 plus this mess and 0.507 minus this mess, if you take a minute to type that into your calculator, you are going to get 0.4915, 0.5223. Okay, so now we can write a confidence statement, right? And what does your confidence statement sound like? What is your confidence statement? Can you remember what that looks like? I'll give you a second to think about it. How are we going to start that off? We are going to say what? We are, so we are 95% confident, right? That what? That the true proportion of coins would fall is between 49, I'm not gonna write that down, 49.15% and 52.23%, right? That the true proportion of coins that would land 50.7% of the time, the amount of coins times that we would get the amount of times that we would get 2048 out of 444 coins would be between 49.15% and 52.23%. Okay, so I'll let you finish that. What is the margin of error? That is another formula that we have done, right? So let's look at the margin of error, and that would be what? Remember, the margin of error is this part without that, so it's the 1.96. I'm going to write it down again just so you don't forget. And that is 0.01542. Again, please, please feel free to pause me and really type these into your calculator so you're okay with that, right? Oops. So the margin of error is plus or minus 1.542%. Not too bad, right? So we are very certain that this is good. Okay. All right. We'll stop there for today. I know that's a lot. You may want to look over this and just go back and think about this. There's a lot of formulas that you have to look at and keep straight. So make sure that you are keeping a good formula sheet again. And I went ahead and circled that on mine. So go through and really look at these. When you go to pull anything out or you go to look at your notes, make sure you have that with you. Okay, I will see you next time. We're going to do a warm up together and then we'll have a little homework, I promise. Adios, amigos.